We will now try to understand the effect of the disturbance in a dynamic system. In this setup, we are using a rotating axis that is visible on the top. All the connections are assembled, so let's see what is connected. So in this setup, we have the bench and the National Instruments USB model. This model is going to be connected to the bench so we can control using the LabVIEW application. So first of all, we need to connect the ground from the model to the bench. So voltage reference are the same. Then we're going to use an amplifier, and this is necessary because the National Instruments model has an analog output that ranges from 0 to 5 volts. So we will need to amplify it. However, this amplification will only increase the voltage from a range of 0 to 5 to a range of 0 to 12 volts. Then we need to use a power amplifier to increase the power available to propel the motor. And we will do this with this power amplifier that's also in the bench. Now we're going to connect the motor 1 to the power amplifier output. And this way we can control the motor and make its speed change through time using the LabVIEW application. So now motor 1 will be connected to motor 2, and we're going to use motor 1 as a normal motor, and motor 2 will be used as a speed sensor. As the motor power is pushed from the first to the second one will produce an electric voltage. And then we will measure both the power reaching motor 1 and the power from motor number 2. And this we will call reference and speed sensor. So the reference is more like a power reference value and that the motor should follow, and the speed sensor, it's the real speed measure from motor number 2. So this is our experimental setup.